Good evening, students. So, again, here we are after a long time. I hope your exams are over. So, here we are with our next topic, which is filters. Means filters in radiology, okay? So, did you know that when X-rays are taken, only 1% of the energy actually becomes the image we see? And the rest is turns into heat. I know that this is somewhat shocking, but yes, it is it. So, how do we manage that all that heat, which is 99% of heat, without even damaging the machine or affecting the image quality? The answer is very simple, just because we use filters in our department. So, in this video, I'm going to talk you through how filters in radiology helps us to improve our images, reduce radiation dose, and to ensure the patient safety ultimately. So let's just start with that what is a filter in radiology actually. Let's just start with the basics that what exactly is a filter. Filters are special materials used to remove low energy, means the soft X-rays that do not actually contribute to the image but leads to the production of heat. So these soft X-rays are usually absorbed by the patient, also do not help in the formation of the image. Instead of this, they just increase the radiation exposure to the patient. Okay, means reduce the radiation safety of the patient. Let's just imagine that you are taking an X-ray of a patient. A patient come to the department and you are just taking an X-ray for that patient, and instead of just showing the image you need, all those extra X-rays just go to the patient. Okay, now this is not ideal, means this is not which we want, right? So filters solve this by blocking all these unwanted rays, okay, and also improve the quality of the image. Now the question is that types of filters. That now that we know that what filters do, let's talk about different types of filters. There are several types, okay, and each of them plays an important role. First one is inherent filter. As I've already explained in a very short note in the image, let's just have a more explanation for that. The first type of filter is the inherent filter, and these filters are already built into the X-ray machine, means we do not add them from outside. These are already built into the machine and naturally filter out some of the, mark this word, that they naturally filter out but some of the soft X-rays, okay, but not all. So the glass window of the X-ray tube, the oil inside the tube, these all works as the inherent filter. We have already know that glass window, oil, which is used for the insulation purpose in the X-ray tubes, are already there. We do not add them from outside, okay. That's why this glass window and insulating oil work as an inherent filter. In other words, we can also say that these filters are like the default settings in the system. They help, but they are not enough, okay. As these filters have advantages, so it is more obvious that they have some limitations too. While these filters do a good job, little bit good job, just by removing low energy X-rays which are soft rays. But additionally, filtering is required just to improve image quality, because these inherent filters are not enough just to remove all the unwanted X-rays. We do need extra filtration for that, okay. That's why we are going to discuss the second type, which is added filter. Now this is where we make a real difference. These filters are placed in front of the X-ray beam to further filter the radiations which are just left from the inherent filters, okay. So this added filter just remove the extra unwanted radiations which are left by the inherent filter, okay. Now let's come to the material from which it is made up of, because it is so obvious that if we are adding something from outside, it should have some material, right? So the most common material which is used for added filtration is aluminium. Why? Because it's very effective at blocking soft rays and very effective for letting go for the hard X-rays. Adding this aluminium filter significantly improves the quality of the X-ray image. Why and how? By just getting rid of more unwanted rays. Now let's discuss the benefits for this added filtration. So first benefit will be it helps us to improve image quality by increasing contrast and reducing the patient dose. Second is that it also reduces radiation dose to the patient indirectly improve the patient safety. With added filter, we ensure better image sharpness but less unnecessary exposure to the patient. This is for the added filtration. Now let's come to the third filter, which is compensating filter. As I've already written over the image, compensating filter. As the name suggests, that it is going to what? It is going to compensate something. So what are compensating filters? They are used to compensate for variations, but where? In patient thickness, because we know that each patient has its own thickness. Some are thin, some are thick, some are medium. So these filters are just going to compensate for those variations. For example, a patient chest, somewhat or sometimes it might be thinner, somewhere it can be thicker, and somewhere it might be thinner than the abdomen. So if we do not compensate for these differences, we end up with uneven exposure across the body, right? So making some parts of the image too light or some parts will appear as too dark. This will create a poor quality of image actually. So types of compensating filter. We have some types also for this filter. First is wedge filter. Second is contour filter. Okay, wedge is a kind of stairs. We have already seen the stairs. So wedge filter is somewhat looks like the stairs. This is used for the thicker areas of the body like abdomen. Why it is used? Just to decrease the intensity of the X-rays. Okay. Now second type for compensating filter is contour filter. It is used when we need to match the contour of the body. Means such as the chest area. Okay. Inside it, it is filled with air. It is covered with soft tissue. So in simple terms, compensating filters make sure that the areas of the body with different thickness get right amount of exposure. Where it is thin, the exposure will be high. Where it is thick, the exposure will be low. So the whole exposure will remain constant. So what is a contour filter actually? It just ensures that we get the uniform exposure across the entire body, leading to a more consistent image. That is it about contour filter. Fourth type we have spatial filter, which is also a last type of filters. Spatial filter. These filters are used for specific imaging needs, where such as mammography or fluoroscopy. Now the material. These spatial filters are made up of copper, also known as copper filters. Somewhere it is also made up of rare earth materials. So copper filters are often used in mammography. Why? Just to enhance the contrast. That's why we are calling them a spatial filter, because they are generally used to enhance the contrast, nothing more. Rare earth filters, just because they are made up of rare earth materials, we are calling them as rare earth filters, which comes under spatial filters. Where it is used and how they are helpful. So they are generally used in fluoroscopy and they helps us to improve the image quality. Basically, these spatial filters are specialized and used only in a specific situation, not in normal situations. That's why we are calling them as a spatial filter, where we need to enhance the contrast only and image detail. Okay, that's why we are calling them a spatial filter, because we need them in a special situations, like where we need to enhance the contrast as well as image detail. So what are the key points to remember about the filters? Let's just quickly recap the most important points. Inherent filters. The first type. Inherent filters are built into the machines and remove some of the soft X-rays. Some, mark this word. Okay. Now added filters. Added filters, material is aluminium. They do the heavy filtration. How? By removing the unwanted radiation and improving image quality. Next we have compensating filters. Where do we use them? We use them in the body parts where the thicknesses differ, just to ensure the uniform exposure. And last we have the spatial filters. As the name suggests, these are used for the specific spatial procedures in fluoroscopy. Why? Just to enhance the image quality as well as the contrast. So in short, we can say that the filters improve image quality, lower the patient radiation dose, and helps us to get the best diagnostic images. So next time when you see a clear X-ray image, remember that the filters played a huge role in ensuring quality as well as the patient safety. Filters are more than just add-ons, okay? They are just essential part of an X-ray machines. How? by improving the quality of our images while keeping the radiation exposure very minimal. So I hope this video helps you understand the importance of filter, also about the basic introduction of filters in radiology. And if it did, please don't forget to like, comment, and also subscribe RadioOneliners. Also, we have the Instagram channels, which is RadioOneLiner. So at the end of this video, I have one question for you. Just drop your answers in the comment box that what type of the filter do you think, from all of the 4 types, that what type of the filter do you think is the most important for accurate X-ray imaging? Let me know your comments in the comment section. Thank you.